Internet Protocol IP version 4 and 6, IPv4 versus IPv6, and secure network protocols. A security awareness training script for CISSP study guide and training video. Welcome to this lesson on IPv4 versus IPv6 and secure network protocols. Every device connected to the internet or a network needs an IP address to communicate. IPv4 has been the standard for decades, but with the growing number of connected devices, IPv6 was introduced to expand addressing capabilities and enhance security. In this lesson, we will compare IPv4 and IPv6, discuss their security implications, and explore secure network protocols that help protect network traffic. Let's get started. Internet Protocol, or IP, is what allows devices to send and receive data across networks. Without IP, computers, smartphones, and other internet-connected devices wouldn't know how to find each other. Every device on a network gets a unique IP address, making sure that data reaches the right destination. Think of it like a home address. If you mail a letter, the postal service needs an address to deliver it. IP addresses work the same way for digital communication, but just like home addresses, IP addresses must be carefully managed to ensure security and prevent misuse. For example, a hacker can attempt to spoof an IP address, pretending to be a trusted system to gain access to sensitive information. That's why it's crucial to implement security measures like firewalls, VPNs, and access controls to protect network communication. Here's how to keep your IP communications secure. Use firewalls and access control lists, ACLs, to filter IP traffic. Monitor network traffic for unauthorized IP addresses. Apply IPsec encryption for secure communication over networks. IPv4 and IPv6 are two versions of the Internet Protocol, each with its own strengths and challenges. IPv4 has been around since the early days of the Internet, but with the explosion of connected devices, IPv6 was introduced to handle the growing demand for IP addresses while improving security and efficiency. The biggest difference between IPv4 and IPv6 is the number of available addresses. IPv4 uses a 32-bit addressing system, which allows for about 4.3 billion unique IP addresses. At first, that seemed like plenty, but with smartphones, smart TVs, IoT devices, and cloud computing, we quickly ran out of IPv4 addresses. IPv6 solves this problem with a 128-bit addressing system, which allows for an almost unlimited number of IP addresses. But IPv6 isn't just about having more addresses. It also includes built-in security features like mandatory IPsec, better handling of multicast and anycast traffic, and improved efficiency in routing and packet processing. For example, a company switching to IPv6 can reduce network complexity because IPv6 devices can auto-configure their own IP addresses without needing a DHCP server. This reduces administrative overhead and makes network management easier. Here's how to transition to IPv6 securely. Implement IPv6 security policies and enable firewall rules for IPv6 traffic. Disable unnecessary IPv4 to IPv6 tunneling protocols, which can be exploited. Monitor IPv6 traffic to detect unauthorized access or misconfigurations. IP addresses enable different types of communication, depending on how data is delivered to its destination. Knowing the differences between these types helps security professionals control network traffic efficiently. Unicast communication is the most common type. This is when data is sent from one device to another, like when you load a website. The data goes directly to a single recipient. Broadcast communication, on the other hand, is when a device sends data to all other devices on the network. This is useful for things like DHCP, where a computer is looking for an IP address. However, excessive broadcast traffic can slow down networks and increase the risk of attacks like broadcast storms. Multicast communication is more efficient for group messaging. Instead of sending a separate copy of the same data to each recipient, multicast sends a single stream to multiple devices that have subscribed to receive it. This is commonly used in video conferencing and live streaming. Finally, anycast communication is all about efficiency and performance. In anycast, a message is sent to multiple servers, but only the closest and fastest one responds. This is how many content delivery networks CDNs work. When you visit a website, the request is sent to the nearest data center for the quickest response time. For example, a large company can use anycast to route employees to the closest VPN gateway, ensuring a fast and secure connection regardless of where they are in the world. Here's how to secure different types of IP communication. Disable unnecessary broadcast traffic to reduce network congestion. Use multicast filtering to prevent unauthorized access to group messages. Monitor anycast traffic to detect potential route manipulation attacks. The internet is full of threats, so secure network protocols are necessary to protect data in transit. These protocols ensure encryption, authentication, and integrity. IPsec is one of the most widely used security protocols. It encrypts and authenticates IP packets, making it essential for VPNs and secure site-to-site communication. If your company has remote employees, using IPsec ensures their traffic is encrypted and protected from eavesdropping. Another essential protocol is Secure Shell, or SSH. SSH encrypts remote access to devices, making it safer to manage network equipment, servers, and cloud environments. Without SSH, administrators would have to rely on unencrypted tools like Telnet, which expose credentials to attackers. Finally, we have Transport Layer Security, or TLS. This protocol secures web traffic by encrypting data between browsers and servers. Whenever you see a website using HTTPS, it means TLS is in use. TLS also protects email communication, VoIP calls, and API connections. For example, an organization that handles sensitive customer data should require all internal and external applications to use TLS encryption to prevent man-in-the-middle attacks. Here's how to implement secure network protocols. Enforce TLS 1.3 encryption for all internet-facing services. Use SSH keys instead of passwords for secure remote access. Enable IPsec for encrypting internal network communication. Now, let's summarize what we've learned about IPv4, IPv6, and secure network protocols. IPv6 offers more address space, better security, and improved efficiency compared to IPv4. Different types of IP communication, unicast, broadcast, multicast, and anycast, have unique security implications. Secure network protocols like IPsec, SSH, and TLS protect data in transit by encrypting and authenticating network traffic. Organizations should transition to IPv6 while implementing strong security controls to prevent misconfigurations and attacks. By understanding IP networking and secure protocols, security professionals can design stronger network defenses that protect against cyber threats. This concludes our module on IPv4 versus IPv6 and secure network protocols.